Here you can see the fully assembled tech we're going to be using for the audio poster project. I'm going to plug it in, give it a little power, and we'll show you how it works. These are our main components. We have a set of very small 0.5 watt speakers. We have our Arduino Uno. We have our Cytron EZmp3 audio shield. And we have our Adafruit 5-pad capacitive touch sensor button. And on top of that, of course, we have it on our mini breadboard. We'll begin by looking at the Adafruit sensor kit. This is how the sensor looks when it's fully soldered. This is how it comes to each group. The sensor kit will have to be soldered and assembled. So it comes like this with no pins, soldered in, and here are the pins. You can see that it has 5 pin slots, so that's what we're, 6 pin slots for our power and for our ground on each side. So we're going to start off by separating, making sure we have 6. Once you have your pin slots, what you want to actually do is mount them into your breadboard, like so. And then we place our sensor board directly on top. This allows us to keep the pins nice and straight. To do this, you're of course going to need solder, and a soldering iron, which we have heating up right now. Try to get a nice close view of this for everyone. Remember when you're soldering that you want to add heat to your pin first and then introduce solder to it after about 3 seconds. So hold heat to it, 1, 2, 3. That should be it. 1, 2, 3. One, 2, 3. 1, 2, 3. One of those does not look very good. We're going to go back in there and try to get it to set in better. There we go. Uh-oh. There's a little bit of fluff in there. Next, we're going to cover the preparation of the mini breadboard. This is just for utilitarian purposes. But you can see that the way that the mini breadboard functions, that it has side rails. The way these side rails work, if you're not familiar with a breadboard, is that the blue one and the red one, which is on each side, actually run lengthwise along the entire side of the board, and all of the inside rails run perpendicular to the board. So what this allows us to do is we can run our positive and our negative along the sides, and then we can of course run pins off of boards and attach wires to our sensor. So to prep this, just to make it easy, what I like to do is I will trim off some hard wire or some solid wire jumpers, which allow me to attach the positive to the positive from one side of the board to the other, because otherwise they don't, and if you do need to power something, this allows you to make sure that the side rails are live. We do the same with the ground. So we have voltage and ground, positive and negative. Make sure you get them into the right pegs. Now we're going to attach our sensor. So we can take a closer look at this, if it'll. There we go. So this is the Adafruit standalone capacitive touch sensor. It has 5 capacitive touch keys. You can see it's the AT42QT1070 chip. There's actually several different versions of this depending on the manufacturer, but for Adafruit it's this one. Plugging it into the breadboard. You can see there's not a lot of room on either side. Now, one of the things that we need to immediately notice is that there is a ground and a voltage, and we need to make sure that those are tied into our breadboard. And that's very simple. that keeps things nice and clean while we continue working and attaching our wires. Next, we're going to take a look at the Cytron EZmp3 audio shield. When you get yours, it will come in a small blue box. The audio shield itself has a USB. You can actually use that for USB flash drive. It has a micro USB out, which you can use for attaching it directly to a computer. It is a 3.5 millimeter jack that you can plug into speakers. This rail I've actually added in, but it doesn't start there. It actually just starts off as a couple of empty pins. So these are for speakers, right, left, left. So you can actually add stereo speakers to it, which is what we're going to be doing. It has a micro SD card slot, which is where we will be actually loading in all of our sounds. And each each group will have a 16 gig micro SD card. It has these selectors, which are actually meant, depending on what kind of board you're using, for communicating with the board. But we are using an Uno, so we're going to be keeping it exactly where it is. There is a reset button. And you can see that it has a couple of its own actual functioning buttons. So it has like a play, pause, a volume up, volume down, previous, next function. We're not really going to be using those, but they can be handy while you're sort of working with the board itself. So if you do choose that you want to solder on some headers there so that you can easily plug in speakers separately, we're going to look at where you can get those. They're just as easy to solder in as any other part, and that would allow you to run your speakers off of also normal sort of pins. When you're attaching it to your Uno, what you're going to want to be really looking for are lining up the pins correctly. You want to make sure that all of these pins line up. There are lots of different kinds of audio, or not just audio, sorry, shields for Arduinos and for the Uno in particular. And the way these work is that the pins themselves translate from one to the other, so you can continue using the Uno the way it works, and then this just adds all sorts of extra functionality. So make sure that you get those pins in properly and then press the board down. It certainly does add some height, which for us is going to be a bit of an issue, but we're going to need to work with it the best we can. Next, we're going to look at how we can take the audio shield and the Uno and wire them to our board. I prefer keeping things color coordinated. So as you can see here, what I have is I have a couple of jumper cables or jumper wires, which there are jumper wires in each group's kit, and I have a series of jumper wires set up based on their color. I have 5 colors and 2 jumpers of each color, plus black and red for ground and positive. So we will start off by plugging in our ground into one of our ground. We will plug in our 5 volts to our 5 volt rail. These two can then be plugged directly into the corresponding rail on the breadboard. Now, when the Arduino is powered the breadboard itself will also be powered. So to test that, this is actually another part that, although it's not in the kit itself, is something that I suggest every group looks at fabricating or getting themselves. You can see what I have here is a 9-volt battery, which is on a basic wiring kit. We've done this in 3D design as well, so a lot of the groups will already have done this. And this I have soldered to a barrel jack, and this barrel jack will plug directly into the Arduino power source. And when I do plug that in, you can see that the lights have turned on, and we can test and see if our capacitive touch sensor is working properly. Now, for the next part and understanding how the next part functions, you just need to understand a little bit about the way that the code is going to work. So the way the code works is that this board, as it's being used right now, it can also be used as a communication board, communicating fully with the Arduino, allowing you to use less wires and actually hook up more of these sensors if you chose to. But we're doing it in the simplest way, which is that the Arduino does not know anything about the board. It is only getting sensor input. So I have already programmed this Arduino, and this Arduino is going to have input pins running in the digital inputs that run down from 7, 6, 5, 4, and I believe it's actually I jumped to 2 because there was something wrong with my third digital pin, so I had switched it out that way. The way that the sensors work, if you have trouble with your soldering and you end up with some of the pins that don't work as well, or you have problems with it, there's also the potential of doing as little as 3 sensor inputs or as many as 5 sensor inputs. So what we're basically going to do is we're going to start wiring the Arduino to the board. So I'm going to, right from my Arduino, I'm going to actually put in a blue wire into digital pin 7, and I'm going to run that on my pin 0 coming off of my capacitive touch sensor. I'm going to take a yellow pin. We can run these side by side a little bit. I'm going to take, a yellow jumper, and I'm going to run that into pin 1. I'm going to take an orange jumper, put it into digital pin 5. I'm going to run that into my sensor number 2. I'm going to put a green pin into number 4, and I'm going to run that into pin 3, and I'm going to run a brown one off of my number 2 digital pin, and I'm going to run that to my number 4. So now you can see that these are hooked up. I'm now just going to move that a bit out of the way, and we will run exactly corresponding wires, and you can see that that already went hot just by doing that. It's actually better to do this with the power off, so I'm going to unplug it. Yellow, orange, green, brown. It does not matter what colors you use. I use these colors only because they are not black or red, which is helpful because those are, of course, voltage and ground, positive, negative. So this allows me to use varying colors without having them get in the way with anything else. Now, as I'm talking about that, let's just quickly take a look at the speakers that you're going to get in your kit, because the speakers also I have wired differently. When you get your speakers, they will come like this, with these horrible little awful, let's see if we can get a close-up on the really awful little wires, and it doesn't take very much for those to come off. And you can actually see that that's what happened here, and it takes 2 seconds to get those off of there. So these are the actual speakers. So what I have done is actually took some of the jumper wire and I cut the two jumper wires, purple and gray, and I soldered them onto the corresponding positive and negative. And this way, when I want to plug them into the board, I just need to make sure that I'm plugging them into the right part. And so, for instance, you can see that there is positive and negative there. So we just got to make sure that purple, which is the positive, and gray, which is the negative in this case. Sorry, that was awkward to watch, I'm sure. And now you can see that the speakers are also connected. Speakers are connected. All of the pins are connected. So let's power this thing up. We have lights.
And because this produce looks a little funky on the outside, you get it for 30 to 50% less than what it costs in a supermarket. And you can feel good knowing that by eating imperfect, you're helping to reduce food waste and protect the environment from the greenhouse gases that rotting food emits.
Each of these wires right now is actually a capacitive touch sensor. As it runs off onto the board itself, when you touch it, you actually affect the electricity immeasurably for you, but for the board, it recognizes it, sends the signal to the Arduino, and the Arduino is responding with a set of code that I have set up that we're going to be looking at next. But just to give you an idea of how sensitive this is.
Fruits and vegetables come in every shape and we work with farms, and because this produce looks a little funky on the outside,
and this is one of those moments where you can press pause. So one of the last things to consider is each group will be getting this set of speakers and have to wire it up accordingly to their poster. You'll have your jumper cables, but there'll be, of course, other wiring considerations. However, if you choose to add a secondary speaker, so for instance, this is just a very cheap little $10 wired, it's not Bluetooth, just a wired 3.5 millimeter speaker. And you can see that if I plug this in to the jack, now I actually have very different volume. Okay, so it's going to be a bit louder, but we're going to go through and listen to this.
Fruits and vegetables come in every shape and size, just like people. And the weird-looking fruits and vegetables taste just as good as the perfect-looking ones.
Sorry, it's turned down. It helps having one that has a volume on it.
Fruits and vegetables come in every shape and size, just like people. And the weird-looking fruits and vegetables taste just as good as the perfect-looking ones.
So you can hear that actually overpowers the small speakers, which almost just act as tweeters at that stage. So that's a consideration that each group can consider as they go. It's not a necessary one, and it may certainly have issues even mounting something like that. You might have to hack it, take it apart, and certainly there's lots of opportunities to work on speaker configurations within the poster, which actually acts as sort of like a housing body for the technology itself. So next we're going to look at the code and how the code corresponds. This is our setup for working with our audio shield attached right now. I have it running off my MacBook. So by plugging it into the micro USB, okay, gives me an I've got a file in there called Touch Poster. All right, so I'm going to open up Touch Poster, and as you can see now, I do have a file there you can see called SDFAT, and that is a file that on their website it actually says to put into the main folder, so that will be included in the brief assets, the project assets. And then in order to play audio files, you need to have a second file called MP3. And then when we go into MP3, you can see that I have 5 different audio files here, and this is the naming convention actually. It'll also use WAV files, but I'm using MP3. And you can see the naming convention is just running them numerically 0001 through to 0005. Now, the source that I used for this, because we're using Adafruit as our example for our poster, I found a audio clip about, or not an audio clip, it's actually a YouTube clip on Adafruit, and I downloaded that, and then I ripped the audio off of it, and then I edited the audio using, what do I use? It's not on here, but oh, there it is. No, yeah, Audacity. I use Audacity for all of my audio work. It's a free file or audio editing software, super easy. Anyway, so I basically just turned these into 5 different audio files, and I can play them.
Fruits and vegetables come in every shape and size, just like people. And the weird-looking fruits and vegetables taste just as good as the perfect-looking ones.
So those are my 3 files basically, and we're looking at them right now. It's actually treating the SD card, micro SD reader, on here as just a reader. So it's actually plugged in right off of that. You could use the micro SD and put it into an adapter and put it in, and as long as you use the same naming convention, it won't matter either way. But when you have it plugged in, from what I understand, it won't work. Yeah, it won't actually work. The buttons don't work while it's being used that way. So you have to unplug it, which is fine for us because that's basically, oh, here, let me put that down. Unplug it. Oh, disk did not eject properly. Yeah, so do that. And the next step, of course, will be putting the code on the Arduino. Okay, now this code to be uploaded onto the Arduino will be included in the project assets. Definitely do anything that you need to do to it, to change it, to make it work better. It is super simplified, and it's not using any type of an array, even though it's perfect code to turn into an array. This way it's just simpler for people to kind of see how it functions. So right at the top you can see that You have to include the Cytron EZmp3 library. You have to include the software serial library, and you have to immediately name the Cytron EZmp3, initialize it. Then you add some of your ints. So you've got what I have here is touch sensor 1, 2, 3, 4, and 5, and these are connected to digital read 7, 6, 5, 4, and 2. We have a Boolean going on here as a toggle switch, so that's true. That just makes sure it basically double checks that it is actually on when it's being touched. Then in our setup, start our serial. This is actually initializing the MP3 player. Then we go into reset device. That is actually setting it to the SD reader so that it's reading the audio files from the SD reader as opposed to from the flash drive looking anywhere else. And you can set the volume. The max is 30. You can set it to whatever you want. Then in our pin mode, we of course initialized touch sensor 1, 2, 3, 4, 5, and by giving it an input pull-up, that actually works so that it can use its own internal resistor to check and keep double checking the pin for sensitivity. Okay, you can read more about that actually if you want to know more about how the input pull-up works in the Arduino website. And then when we get into our actual code, and this is basically where the array would have functioned really well, but we're just doing it really simple here. So this is just the it's an if statement. So if digital read touch sensor is low, because it's actually on high, and if it recognizes the toggle is true, that's the Boolean, then it will play MP3. It'll go, sorry, MP3 and play track 1. This part here, while digital read touch sensor 1 equals low, delay 20. So this basically says don't keep reading more touches. So without this line here, every time you touch it, it would restart the same file over and over and over again while you're touching it. Even while you're touching it, just touch, 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 touch. It just keeps on going. Whereas now it plays the file without repeatedly recognizing more touches of the same button. If you touch other buttons, you can jump right into those files, and it basically just reads right through. And again, this is why an array would simplify this, but that's the code. It's actually super simple. Okay, right now it's uploaded onto this Arduino and the Shield already. This is all wired to go so that when
And because this produce looks a little funky on the outside, you get it for 30 to 50% less than what it costs in a supermarket. We work with farmers to source their ugly produce. Like these carrots and vegetables come in every shape and size. Unfortunately, supermarket... What if you could live in a place where perfectly edible fruits and vegetables...
So you can also see that what I have going on here right now is I don't have the speakers plugged in because the speakers are quite loud and tinny. I'm just using my little speaker, and I can easily come in here and turn that way down. That way, while I'm working on this, I'm not having to listen to it really, really loud. You're going to find that you're going to need to have your own kind of setup for how you're going to work with it. This is the basic tech setup. This does not include, of course, how you will wire this in for actual when you're adding your paint and all the rest of it to it. We're going to cover how the conductive paint works in the next segment, but this is to get all of your technology soldered, assembled, and your code installed and working. For the last part of this demonstration, what I'm going to show you is how the conductive paint works along with the sensor button and the capacitive touch sensor pad the Arduino, the audio shield. So again, I'm just using my small speaker. Now these are actually the materials that these touchpads or this capacitive paint that I'm using. So this is graphite, which is a conductive mineral that you can use. And when you add it to a material, it conducts electricity. So this is mixed just with some golden acrylic. We'll be using something slightly different for our project, but it's basically the same thing. It is the graphite being suspended into the acrylic as a medium, which is why it's a black color, because the graphite itself is black and it discolors any other paint. So these are some sort of button painting type things that I had previously made using this conductive paint mix. You can see that I have my battery connected. I have everything connected. I have to each of those wires. Right now I have an alligator clip that is then attached, just attached to the painted area of these sort of small canvas pieces. So you can see each one. Thing to remember here, the important thing, is that each of these wires is now a circuit. So because it's a circuit, they cannot cross. Each wire has to be, from the moment that it leaves the sensor pad, it needs to be, well, you can hear how it actually picked up. It actually picked up me getting so close to it. And you'll find that these pads themselves can actually conduct electricity without actually being touched. And depending on how much of the material you put down, you can actually use them as proximity switches. However, in this case, I'm just going to show you how they're working as buttons. So now if I were to touch...
Vegetables come in every
you
shape
see,
and
I didn't
size,
even touch it.
just like people. And the weird-looking fruits and vegetables taste just as good as the perfect-looking ones. Unfortunately, supermarkets reject the
Did not touch that one either. Just came within about a centimeter of it.
And because it's... What if you could live in a place where perfectly edible fruits
Sorry, I was leaning over this one.
are not only saved and enjoyed, but available? We work with vegetables, come in vegetables, come in every shape and size, just like people. Vegetables come in every vegetables.
And you're going to find that this can happen.
Like and the weird-looking fruits and vegetables.
Turn that down a bit so you can see how that switch is on. And what you're going to find with your testing is you're going to need to keep track of your circuit, because the circuit itself can go off. You can see there now we've got it. I think that it was actually being affected somehow by the board. But anyway, now you can see how if I... And it is letting go. All right, so that's a good example, because it's important to realize that this is going to take some care. You're going to be really careful with this material, because
vegetables come in every shape and size. Vegetables come in every shape and size.
There's a bit of a glitchy thing going on there right now.
Come in every shape and size. Just like people. Vegetables
and it could
come
be
in every
the
shape and
pad,
size.
it could
just like
be
people.
the wire itself,
And
so
vegetables come in every shape and size. Just like people.
and I guarantee that if we just unclip that one,
vegetables come in every shape and size, just like people. And the weird-looking fruits and vegetables taste just as good as the perfect-looking ones. Unfortunately, supermarkets reject the produce that doesn't look perfect. That leads to 6 billion... What if you could live in a place where we work with farmers to source their ugly produce. And because this produce looks a little funky on the outside, we work with farmers to source their ugly produce. And because this produce looks a little funky on the outside, what if you could live in a... What if you could live in a place where perfectly edible fruits and vegetables are not only... Unfortunately, supermarkets reject the produce that... Unfortunately, supermarkets reject the produce that doesn't look perfect.
So that shows you how it basically works, and that you're going to have areas that could have little glitches you're going to need to figure out. Could mean changing, it could even be where it is, if it's too close on the Arduino board itself. I've heard there's been moments where there's a bit of a crossover of signals, so maybe even spreading things around on the digital pins a bit more. There's going to be a few different ways to deal with that, but it's going to be a lot of creativity coming up with solutions. All right, that's it. That's the last part of the demonstration.